Hi. Before we dive into the first technical chapter of this course, I wanted to set the scene a bit. I have invited Matti van Hoof to join us. Matti has a PhD on the security of wireless networks, and he is still working on breaking them. In fact, his work was partially responsible for browsers deprecating RC4, one of the most used algorithms in HTTPS. So I could not think of anyone better to paint a scary picture. Hi Matti, thanks for joining us.
It's a pleasure to be here.
So, you're working on wireless security. So let me open, well, first of all, Wi-Fi networks are essentially everywhere. So everybody's using Wi-Fi. But is security really that different in a wireless network than compared to a wired network?
Yes, it is, because if you look at a wired network and you want to gain access to a wired network as an attacker, you would need physical access to the cable, which generally means you need access to the building, you need to get inside and somehow find the cable in order to plug into it. However, with a wireless network, you simply have to be nearby. So you can park your car on the parking lot and try to access the wireless network from there. Or there are even techniques that you can access a wireless network from up to a kilometer or two away. So it becomes much easier for an attacker to access your wireless network. So it definitely increases the risks.
Really, 2 kilometers away to access a wireless network?
Yes, they pulled that off. In one case, they even used Pringle cans to enhance the wireless signal. So it can even be done quite cheaply.
Okay, that's definitely a big change compared to wired networks. So with wireless networks, we have all these different types. We have an open network, but you also have networks with passwords. Can you elaborate a bit on the differences between those?
Yes, so you have an open network, which of course means that there is no security. So anyone can connect to this network, and all the data you transmit over it can also be intercepted by people, so they can read what you send over that network. Yeah. You also have networks where you have to use a password, and that is of course more secure, at least if no one else has the password. So for example, if you are at a hotel or at a conference or maybe at a coffee shop, everyone knows the password to this network, and that would still be a risk. And then you also have the more professional networks where you have a username and a password, and I would say those are the most secure ones.
Okay, that's good to hear. So everybody talks about, yeah, you can listen to a wireless network, blah, 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 but nobody really knows how that works. So when people talk about this is a hypothetical problem, and it seems like hard to do and only a few people know how to do it. But you prepared a demo when you came here, right? So we're gonna actually do it right here in the studio, and we're gonna see how eavesdropping on the network works. So what I'm gonna do is I'm gonna visit the demo application for this online course, and you're gonna have to see if you can grab the signal from my cell phone.
Yeah. So I'm just
what's gonna happen now?
So here I'm just using my normal laptop. Basically every laptop with a Wi-Fi card you can use for this. So anyone can do this, they just need to install Linux, and then they can do the same things as I'm going to do now. Okay. So what I did here, I took my laptop and I configured my wireless chip to listen to all the nearby traffic. And now I'm going to listen to to our network only, so we don't intercept other traffic, and we're going to try to intercept your requests that you make.
Yeah. Okay. So our network is called Open Network. Kind of obvious what the thing is supposed to do, and my cell phone is already connected to it. So
okay. So let's now start the capture here. So we have our wireless interface. We're going to start monitoring packets. And I now have it set that so we only see the traffic that you transmit. So currently we don't see anything. So if you now visit, for example, just any HTTP website, we should be able to capture it and see the website you are visiting to.
Okay, let's try this out. So let me go to the training application for this online course.
Okay, and we already see the requests here. So apparently you visited BeerSafe.
Yeah, yes, indeed. BeerSafe is the application that we're going to run the labs on during the course. Yeah. So it's an application to keep track of tasting notes for beer. So
interesting.
You might be interested in that.
Yeah. Of course.
We're Belgians, of course. So yes, so can you explain a bit what you see here in the request? So.
Yeah. So here we see the request being made to the website. We have HTTP requests. They are unencrypted. And because they are sent over the unencrypted wireless network, we can intercept all these requests For example, here we see the HTTP request. We can see that it is indeed to beersafe.eu. We can see the cookies being sent and all other kinds of information.
So you can see the actual information. So if I log into this application, you will be able to see the username and password.
Yes, we should be able to capture that. Yeah.
Let me try if that works. I'm obviously not going to use my real username and password.
It's a good idea.
Let's see what.
And here we already see it. We have the post request here, which submits your password and username to the website.
Yeah.
So let's try to find it here. Here we have the data that you have sent, and it should be in here. So as you can see, your username was hello, and the password in this case was Matti.
Yeah.
So we got it.
Wow, that's amazing. So it's really not that hard. Well, probably the hardest part is installing Linux, right?
Yeah, exactly. I mean, you can Google for this, how to capture unencrypted wireless traffic, and you will just see a step-by-step guide. And if you have a laptop, you can do this yourself. It's really easy.
Wow. Okay. And actually, in practice, it can be even more easy. I brought a device here. It's called a Wi-Fi Pineapple. You probably know what this does.
Indeed.
So this is a, well, maybe you should explain it.
Well, I know the basics about it. So the interesting thing here is that here the user had to actively connect to our network. But this Wi-Fi Pineapple, it can see the networks that you previously connected to, and it can imitate those networks.
So if I'm connected to the library network occasionally, and I come here where the library is way too far away, this thing will be able to mimic that network?
Yeah, exactly. Or if you used to connect to an open network at an airport or at a coffee shop, it will see the name of the network that you used, and it will basically clone this network, and your device will automatically connect to it, and then we can intercept traffic like we have just shown.
Okay, wow. And it can do a lot more than simply listening to the traffic, right? You can start manipulating and modifying things.
Exactly. Because the Pineapple, because it sets up its own network, it can not only just intercept traffic, it can also modify the requests you make and inject content into websites you visit. So for example, it can inject ads, that's done a lot, but it can also inject viruses or malware to try to really attack your PC specifically.
Wow, okay, so wireless networks are less secure than wired networks.
Yes, you should not use open networks.
Open networks, okay, I'm gonna try, but as you said, airports, they only have open networks, and of course you need internet access, so
a lot of people do it, and it's a problem.
Okay. You mentioned wireless networks with passwords before, but those are a bit more secure, but if everybody knows the password, then that security goes away, of course.
Yes, exactly. So if your password is secure and no one else has it, then that's a good solution, as long as you have a complex password. Otherwise, you can still guess it. But let's say that you're at a hotel or at a conference or maybe at some kind of coffee shop where everyone knows the password. Well, in that case, the attacker can simply set up an exact copy of the network with that password as well. So an attacker can still intercept everything that you send. It can still monitor all the traffic, and it can even inject content into websites. So if someone else knows the password, it's basically the same as running an open network. You don't have any security.
Okay, that's really surprising. Wow, so indeed, that's not a good thing. But between us, even if you have a password that nobody else knows, you'll be able to find it, right?
There are some techniques to still do it. So you can automatically try to guess a lot of passwords. So if you use a weak one, we can crack that. Even though if you use a strong one, it's still possible to attack it. For example, there was a flaw in Wi-Fi protected setup, WPS, and that can sometimes be abused to still gain access to the network.
Okay. That's very good to know. I don't think many people realize that. They think, oh, I have a password, it must be safe. And you can go even further, right? You're doing research on breaking even the more complex security systems in wireless networks?
Yes, exactly. So we recently found a flaw in the Wi-Fi standard itself. And this allows you to attack most devices, even though they are fully secure and use all the recommended practices. So configuring a Wi-Fi network on Wi-Fi devices to be fully secure, it's a very difficult task.
I can imagine, and most users have they just plug it in and hope it works, and
Exactly.
if it doesn't, then
yeah.
they're already stuck, so it's a nightmare. But to be honest, this course is not about setting up wireless networks. This course is about building secure web applications. So my main question is, well, a lot of people know that HTTPS actually helps against these kind of things. So would HTTPS help in this scenario? What does it offer, and how can it help remediate insecure networks?
Yes, HTTPS would definitely help here. The reason that is the case is because when you visit the website using HTTPS, the HTTPS protocol makes sure you are talking to this website and nothing else. So you are sure that you are communicating to the website that you want. And on top of that, it also encrypts your traffic, so no one can see what you are sending. And it also authenticates your traffic, which basically means that no one can modify data or inject content into a web page. So let's say you are connected to an open network. If you then use HTTPS to, for example, log into a website or send your credit card information, then an attacker would not be able to attack you, because HTTPS takes care of all the security risks. So that would definitely help defend you.
All right, thanks. So even if you're on an insecure network, if you see the green lock icon and a green URL bar, even in some cases, then you're probably sure that it's the right website.
If you use a protected Wi-Fi network, your data is essentially protected until it goes to the access point. In other words, it's only protected on the first hop of the internet, but everything beyond that, it's still unencrypted. HTTPS, however, assures end-to-end encryption, meaning it's protected all along the way when your traffic goes over the internet.
Yeah, so essentially it protects the traffic from the browser till the server, and everything in between is not able to read or modify the traffic without being detected.
Yeah, so with HTTPS, you know that it's always protected until it reaches the server, but with Wi-Fi, only the first step is protected, and beyond that, it probably is still unencrypted.
Okay, of course. And we talked about websites, but I had a phone before, and mobile apps, they use HTTP traffic as well, but you just don't see it, right? So you don't know whether they're using HTTPS, is that correct?
Yes, that's indeed one disadvantage. If you are using an app, you don't know whether it's using HTTPS or not. So you might be at risk if you use apps.
Thanks a lot for the explanation. Thanks a lot for the demo. I think that's going to be an eye-opener for a lot of people, how easy it actually is to capture this traffic. Yeah. Before we say goodbye, do you have a key takeaway message? So what can you recommend developers across the world and users of websites to remain secure, even when using open networks, when they have no choice?
Yeah, so I would say the best option here is to use HTTPS and to properly configure it, of course. But that's the best defense that we have, because as we mentioned, sometimes you're at the airport, you only have an open network to use, and you want to be secure even in that case. And then HTTPS is one of the best options you can use. So I would definitely recommend developers to make sure that their website is accessible over HTTPS.
Yeah, okay. Thanks for the practical advice. That's exactly what we're going to cover in the remainder of this chapter. So
you're welcome.
Hopefully, after people have attended this course or followed this course, they will be able to deploy HTTPS for everything. Thanks for being here.
You're welcome.
So, as I said, in the remainder of this chapter, we will look at how to configure HTTPS correctly and how to make sure that your entire website runs over HTTPS.